Well, greetings. In this log, I'm going to show you the first program, the first interface that we have created for the artificial intelligence assistant. And I'm showing you this picture and not the real one because I just broke the screen. This was a resistive touch screen of 5 inches, which was connected to a Raspberry Pi, as you can see here. It is a very popular touch screen, but I don't really recommend it because the touch is not that good, and besides it uses a pencil to be better, but it's better using a capacitive touch screen. So besides that, we had this case that we have downloaded from Thingiverse, but the device was too small for the program that we have created. So anyways, we have just bought a new capacitive touch screen of 10.1 inches, and the next video is going to be about that. So let's start. In this video I want to show you the first program that I have made. Why? Because it took me a while to do, and I guess that as a first prototype it developed the second model that I am going to show you at the end of the video. So let's start. First of all, let's go to the expert system that we have developed a month ago, and so it had these features to tune an expert system, and it had 4 output levels, and after a review that we have done with some doctors, we have determined that some of the symptoms were not giving the correct information to the model, so we have just eliminated them. And you're going to see that in another log, which is called upgrading the expert system knowledge. And the program that I'm showing you right now is going to be the first one with this model over here. Okay, so let's go there, and I have created this file, so then we just execute this, and it's called main. Alright. So let's start. Let's wait for this, and okay, so this is the program. As you can see, this is an old program. Well, it's the first one that I have done a few months ago, and it's using Python, and it's using Kivy. What's interesting about it is that it copies the backend from Open Medical Records, and it's all in Python now. So I really like Python, so I guess that it would be useful to some people now. Why do I say that this is old? Because, for example, the first design that we have made for this assistant is that it was connected to the box, box to store and collect biological samples, and it had a serial port to show the moisture and the temperature of the box, so you have that data displaying over here. Besides that, you had these two options: to open the doors or to close the doors to maintain it safe. And let's start with the options that I have copied from Open Medical Records. So as you can see, the first prototype was very simple. You had only the options to enroll, to find, to report the database, and to remove the database. So let's start by enrolling a new patient. So let's go. It asks you for the name, so let's use Khalil name. Alright, that's Khalil, and his birthday, well, to be honest, I don't know, but let's say that okay, he was born in this date, which doesn't matter, so he's a male. And then we just go to the next one. So the residence, it's gonna be, I don't know, Calicoto, and his telephone, which I don't know either. I don't know that number. All right, so let's mark him as an active patient, and then let's choose the country. So yeah, oh my god, there was Bolivia. So this is Bolivia. And so after taking that data, we now know about the patient, and The next thing that you have is this big list, which contains the features that you can see in this log over here, and it's got its knowledge stored in a text file, which is encoded as these binary numbers. So let's say that I have TV. So no. Yeah, let's pretend that the patient has TB. So for example, we choose loss of appetite, we choose weight loss, and we have a fever, and what else? We're coughing for longer than 2 weeks, we're just coughing up blood, and what else? Let's pretend it is a very poor area. So I don't know if I've written about this, but the WHO reports that poor areas are better related to TB's prevalence. So let's compute this, and the result shows me that we must take a sputum sample. So this is very useful for the person that is taking the sample, because one important factor that we have detected at the diagnostic is that a good specimen collection should be achieved, and so I'm going to show you that in these images. So there is not a description in these screens that you are going to see, because I just left this program to build a better one. But the idea is that you just have a set of pictures that show you how to take the sample. So for example, you are going to need this container, and this is the kind of biological sample that you must take. And so after you press next, it tells you how are you going to take the sample, by cough or induced. So using induced is using a chemical that the patient has to take, and then he expels a better sputum, but hard to take in remote places. So let's just say that we're using the conventional way to take the sample. So after that, you have a screen which shows you what kind of biosecurity procedure you must follow, I mean the equipment, and this is very important because TB is very contagious. So after that, you have the equipment, then it tells you the patient should clear his mouth, then he should breathe in and out 3 times, and then that's when we say that we have a good sputum sample, but it does not end there. So let's move to the other screen, and this is a very important factor that we have also detected in the research the last month in that laboratory. And there are different types of sputum. So in 90% of the cases, the bloody and the purulent sputum have TB, because it's a very deterministic symptom that the person is got TB. And so the person that is taking the samples should be very careful, because if he does not have a good sputum sample, then the whole procedure is worthless, and it's just going to be a waste of time. So this is the only way to detect this kind of sputum. It's very hard to do. So showing the person which is good and which is bad, because for example, even in big hospitals here in La Paz, personnel, I mean the nurses, tend to take mucus instead of sputum, and so that gives then a false positive, and it's a whole mess, because you don't detect TB on time, and the person keeps spreading the disease, and well, that's just a very complicated thing. So with these devices, we hope to improve that. So after you have the sample in the container, it shows you this this schematic that represents that the box that we have created, which is named the box to store and collect biological samples, and it basically has 2 floors. So it has 10 compartments on each floor, and you can take you can pick a place to store your container. So let's suppose that we store it right here, and so this is going to be marked until we unload the sample, and so that takes us to another step. In this this time I'm going to show you how to find a patient, and the basic thing that you had was this, right? Here this spinner displays all the patients that we have acquired. It shows only the raw data, but the new one uses MongoDB. So and besides, I have organized it better, as you will see. But you have, for example, this one, and so you press next, and you can see this data in a more organized way. Right, so you could also use this text input to pick your patient. So the next one was to report the database, which had two buttons. The first one, that is report data to central server, which as we're using a Raspberry Pi 3, we have the ability to use MQTT through a local server, or even through remote distances if there is internet. So you just press this button, and this is going to report the data of a patient to via MQTT to a center, right, with a determined topic and a message. Another option that you have is that, for example, you just took the samples and you have the box full, so you go back to the laboratory, and there you have this option to unload the samples. And so it's basically the previous screen that I have shown you. I'm sorry, but with the floors and the names of the patients, so you can unload the samples. And the last one, well, which is not interesting at all, is just do you want to erase the database, and so you just set a password, and the whole thing is going to be deleted, but we're not going to do that. So that's it for this program. Just because this is taking too long, what is this, the MongoDB, I'm going to show you the new program, which is going to have a whole video, but just to show you that the new one is better. So as this is loading, we're going to wait a little bit. Come on. Okay. All right, finally. So in this program, you have now users and passwords, so you can just log out. You can just take your location to have more organized data. You can, for example, schedule consultations, so you can just do this and go here and pick a date, and then it's going to display you the information, etc., etc. And you can just pick your language, and as you can see, it's just a better interface. You can even take pictures. Okay, that's not going to work because right now I'm using the webcam. So in the next log you're going to see that, and it's more complete, as you can see. And now it's got a MongoDB interface, so everything is more organized and it's easier to handle the data. So just to show you a little bit more of this, and for example, this option that you can see over here has the new expert system that we have built. So for example, we have built the new model to suit the needs of respiratory inspection, so that you can just you have more options and a better design about this, based on a real procedure for making diagnostics. And with this you have digitalized information, not a messy a lot of papers that show you different data about the patient, and besides you have some sort of artificial intelligence that is going to help you in the diagnostic. So that's for the other video, and I guess that's it for this.